In this video, we will be looking into the chapter Trigonometry. Trigonometry is the branch of maths that deals with triangles and angles. So in the title, tri means 3, gono means angles, and measurement means measuring. Metry means measurements. The 3 angles measurement, that will be the translation for the word trigonometry. So in this chapter we will be dealing a lot with right angle triangles. So among the 3 angles of a right angle triangle, one will be 90 degree. So in this triangle, let B be the 90 degree angle, and the relation between the angles and the sides of the triangle is given by trigonometry. So we already know relation between the sides and the hypotenuse by using Pythagoras theorem. What does Pythagoras theorem say? Pythagoras theorem says that the square of the hypotenuse of a right triangle will be equal to sum of square of the sides. So if we square this side and add these two values, we will get the square of the hypotenuse. This is what Pythagoras theorem states. Now similar to Pythagoras theorem, states the relation between the 3 sides of a right triangle, but in trigonometry we have ratios that will give relation between the angles and the sides. For example, let us consider angle A. I'm going to name this angle as theta. Theta is a Greek alphabet. It is just like a variable, and this variable I'm using to denote this angle A. So we can say sine of theta is equal to the side that is opposite to the angle. So angle theta opposite to that angle is the side BC divided by the hypotenuse. So opposite side divided by hypotenuse. The sine of theta can also be written in the short form as sine theta. So in this sine theta, it is not like sine multiplied by theta. Sine is actually a function. That function says you need to take the ratio of the opposite side and hypotenuse. So sine theta means the sine of theta, the ratio of this angle. Similar to sine, there are 5 other trigonometric ratios. They are called trigonometric ratios. So first one is sine, and sine of theta says angle opposite, side opposite to the angle divided by hypotenuse, and it is also represented as sine theta. Now the second trigonometric ratio is cosine. And cosine of theta says you need to take the ratio of the adjacent side to the hypotenuse. And cosine theta is written as cos theta. So in this triangle, cos theta will be the adjacent side to the angle, so that will be AB divided by hypotenuse is AC. So cosine theta. Then the third one is tangent. For tangent of theta, we need to take the ratio of opposite side and adjacent side. and the short form will be tan theta. Fourth ratio is cosecant. And for cosecant of theta, we need to take the ratio of hypotenuse divided by opposite side. And cosecant is written as cosec theta. And the fifth ratio is secant. Secant of theta is the ratio of hypotenuse divided by adjacent side. And secant theta is written as sec theta. And the last ratio is cotangent. And for cotangent of theta, the ratio is adjacent side divided by opposite side. So cotangent will be, short form is cot theta. So for this triangle, we wrote sine and cos theta, and tan theta will be the opposite side divided by adjacent side. So BC divided by AB. The same way we can find the ratios of cosecant, secant and cotangent of the theta. So these are all the trigonometric ratios of this angle A, angle theta. So angle C will have the ratio value as different. So for angle C, we will consider AB as opposite side. So in this triangle, A, B, C, B is a right angle. So sine of A will be equal to BC by AC. BC is the side opposite to A. But sine of C will be equal to side opposite to C. So that will be AB by AC. So the ratio should be taken according to the angle which we are considering. So there are several relationships between the trigonometric ratios also. If we look at this slide, sine theta will be equal to opposite by hypotenuse, and cosecant is equal to hypotenuse by opposite. That means sine theta and cosecant theta are inverse of each other. Sine theta can be written as 1 by cosecant theta, and cos theta can be written as 1 by secant theta, and tan theta can be written as 1 by cot theta. If we look at this slide, we can understand it clearly. So sine theta is opposite by hypotenuse. 1 by sine theta will be hypotenuse by opposite, which is cosecant theta. Same way for cosine of theta, adjacent by hypotenuse. If we take 1 by cos theta, that will be hypotenuse by adjacent, which is secant theta. Tangent theta also similar to that. But there is also a relation between sine, cosine and tangent. So tan theta can also be written as sine theta divided by cos theta. Tan theta equals 1 by cot theta is one relation. Tan theta equal to sine theta by cos theta is another relation. How? Because sine theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse. So if we divide sine theta with cos theta, both the denominators will get cancelled and we will be getting opposite by adjacent, and opposite by adjacent is tan theta. So these are the relation based on the relation between the trigonometric ratios, and based on this relation we can also say that sine theta into cosecant theta is equal to 1. Secant theta into cos theta is also equal to 1. Tan theta into cot theta is also equal to 1. So these are the relation between the trigonometric ratios. Now the value of these trigonometric ratios are unique to every angle. So again the same triangle A, B, C. So if we consider a different triangle but the angle of A is same, then the ratio will also, the value of the ratio will also be same. Let me try to show it to you. So sine A will be equal to opposite side by hypotenuse, which is AC. If I draw a different triangle like this, the angle A is common, but I am just changing the length of the sides, and this new triangle I will call A, M and N. Now we can say the triangle ABC and triangle AMN are similar. They are similar triangles because they are having same angles. So if they are similar triangles, then we can say that AM by AB will be equal to AN by AC. Since they are similar, we can write it like this. And in this, if we take this AN to the left hand side and AB to the right hand side, we will get AM by AN is equal to AB by AC. Now we can also say here, so let's take the cosine of this. Cos A will be adjacent side AB by AC. So AB by AC is the cosine of the angle A. So this can be also written as cos A. So it doesn't matter which triangle we are considering, ABC or AMN, the cos A value is always going to be same because it is the value of the ratio, and the same is true for all the trigonometric ratios. It doesn't matter which triangle we are looking at, as long as the angle is same, the value of the ratio will also be the same. If you have any doubts so far, we can discuss in the comment section. Thank you.